Continuing, we have been asked to continue the online classes itself. So most probably, if possible, I'll try to complete the unit 4, whatever the theory part is there and whatever those are there, I'll try to complete that through the online. Some numerical examples has to be discussed. If time permits, if it has been allowed to take offline some days, at least for 2 or 3 days, I'll try to continue there, or I'll try to just brief out some of the numerical examples in the online class itself, right? So I'll try to allow you to unmute yourself for a few seconds. I hope I'm audible, right? If in between, if you are getting any issues, like I'm not able to, I'm having a network issues, if from my side, you can just raise your hands. You can just post the message in the chat box, right? So to avoid the interruption in the class, I'm muting you all. So you can just raise your hands. And if anybody are using in the laptops, if they are logged into the laptops, or if you have a good internet connection, you can also switch on your videos, which would be better because this meeting is completely recorded. Yes. So coming to today's topic here. So as I said, I'll be trying to show you first I'll be discussing about what are the contents I'm going to discuss, as said already. So if I try to go with the whiteboard, I'll just try to write already I have given in the topic in my meeting itself, but just I want to try to ask you to note down here. First, I'll be discussing about the parts of faults here mainly. So this is the next secondary structure in structural geology. So I'm going to discuss about the same, whatever I discussed for the faults, parts of the fault I'm going to discuss. And after the parts, whatever the classifications are there, right? So like if I talk about the classifications and types of the fault, which I'm going to discuss today, classification and types. So similarly, I've discussed classification and types of faults also. So in the same way, I'm going to discuss classification and types of fault. And after that, third, I'll go with the whatever the causes and effects of fault. So similarly, I'll go with the third secondary structures also, that is joined in a similar way. So maybe I may require about 3 to 4 hours. Maybe I may take 1 or 2 extra classes in this week to complete this unit 4. So this unit 4 will be completed or will be winded up by this week. And also, actually, we have already planned with the guest lecture in the starting of the semester itself. So if possible, I'll try to approach one of the senior scientists from Geological Survey of India, Balachandra sir. He may give a talk on application of geology in civil engineering, right? So that guest lecture will be some informative for you to understand the subject overall, which is actually some small topic, or I can say most of the complete topic is dependent upon the application of geology in civil engineering is in unit 5. So the unit 5 portion will be covered, and also the guest lecture will also be completed. So in that way we are planning. So I'll let you know by end of this week. So these are the content which I'm going to discuss today, right? So I'll immediately move to today's presentation. So you can just note down this, right? So that you can make a note of that. What are the contents which I'm going to discuss? Moving to so these are the already discussed topics, like what is faults, right? And later on, what is joint and a fault? What is the difference between them based upon the relative displacement happening in a rock bed or rock strata, right? So coming to the magnitude of fault, also have discussed. As already I've said, whenever I talk about the magnitude of fault, I am talking about the main is the tectonic force. If whatever the forces acting on the rock bed or rock strata is more, then it would be considered as a fault is about to occur, right? So moving further, and nature of the fault also, if I talk about the nature of the fault here. So in the nature of the fault, as discussed already, any fault plane if you take, how we can study the fault plane, here. So if I talk about the fault plane here, so we may say it as a fracture plane or a fault plane. So similarly, if I take this a rock bed or a rock strata, so whatever the fracture plane or the fault plane happening, which will try to divide this rock bed or rock strata into two halves. One half we usually say that as a footing wall block, and another we say it as a hanging wall block. If I say this as the hanging wall and this as the foot wall block, so these both are separated by a fault plane. So how this nature of fault plane will be? Would it be a straight? Would it be a inclined, or would it be a vertical? So that all is about the nature of the fault plane. And recurrences of the fault plane is all about how the fault plane is about to occur. As I was saying about in the magnitude of fault, how usually we consider a fault has happened in a rock bed is based upon the shear resistance, which is overcoming any tectonic forces acting on any rock bed or rock strata. If a tectonic forces are acting on any rock bed or rock strata, then we usually say that as their fold is happening. That is usually which are bent upwards or downwards. So that folds is happening in a rock bed. But if the shear resistance is more, then we say it as that faulting has occurring. Right. So that is all about the recurrences, or we can say occurrence of a faulting. Moving further, today's topic, that is parts of a fault. Right. So coming to the parts of the fault here. So whenever I say parts of the fault, so always remember I'm talking about whenever a fault happening or a faulting happens in any rock bed, which parts you need to consider to understand or to try to learn the. Yes. So whenever I talk about the fault plane, which is the first part you need to understand here. So coming to the first part here, you can see first part, which is a simple fault plane, or visually say it as a fracture plane, right? So whenever a rock strata, rock bed you consider, so the first part you need to consider to understand or to study the faulting in a rock bed is fault plane. So what is this fault plane? It's a simple fracture surface on the either side of the rock bed. As always, I was drawing the same figure, like showing you just writing a small notation as FP. So this is a fault plane. So it is just a fracture surface which will try to separate the rock strata into two halves, right? So in other words, we can say fracture surface on the either side of which the rock has moved past one another. So since it is divided into two halves, one part on the left side that may move upward, and on the right side that may move downward. So that movement of upward and downward, or if the movement of past one another, is called as fault plane. And its intersection with the horizontal plane gives the strike direction. As already I've drawn you, like for example, if I try to draw a simple rock bed in this way, a small block-like structure. So in this block-like structure, what happens if a fault has happened here, right? So if a fault has happened here, so you can just draw with respect to the horizontal. That will be my strike. So it's second point. And third point is all about the direction along which the fault plane has maximum slope to its drip direction. If I try to explain that with the help of an image, you can clearly understand that strike, the dip, and whatever the point I've mentioned the previous slide with this image. Like you can see, you can see this is the fault plane in this case. Why this fault plane has occurred? Whatever the tectonic forces, moment has happened. What is the tectonic forces? Usually a rock bed is there. These are the horizontal beds you have seen. Try to draw again. Try to take another color. Yes. So if I try to draw a simple rock horizontal beds, which are horizontal, they are not folded or they are not undergone any faulting. If I name them as 1, 2. So whenever compressive forces acting on them, that is the tectonic forces or the tectonic plates moving towards each other. So then what happens? This leads to a folding upwards and folding downwards. That is the fold. So similarly, you can say if this tectonic forces is not sufficient, or if the tectonic forces exceeding some force is there, that is the shearing force. Because of that, faulting of the rock bed happens, right? So that is what a fault fracture you will see whenever a faulting of a rock bed happens. A simple red line which I have drawn, that is our faulting plane, which is the first part, because of which it will divide the rock strata into two halves. One half may be moving downwards and another may be moving upwards, right? So if I take this horizontal, you can see here I've drawn a black dark color. You can see this is the strike. I'll try to draw with the other color so that you can understand. Like if I take yellow, which is representing a strike here. Take darker green. Yes. So which is representing a strike. So in the same way, you can clearly understand what is actually a strike here. This whatever thick here blue color I've drawn, that is the strike, which is that with respect to the horizontal. And whatever the slope you see where the fracture plane has happened, that is the, we can say it as a dip or true dip. So to be precise, I'll try to draw with respect to this strike. So you can see this. So you can see, sorry. So you can see this fracture plane and the dip are same or parallel. That's what the third point I've mentioned. The true drift will be always along the fracture plane with a maximum slope, right? So I hope I'm clear. The first part of fault. Moving to the next part here, that is the footwall and hanging wall. Simple, as I've mentioned, whenever I talk about the fault plane, so after the fault plane, whatever you see, the exact rock strata dividing into two halves, dividing into two halves, you can see this fault plane is what the fault plane is inclined, right? So this fault plane, wherever is inclined, so below this fault, what I can say, this is upper part, and this is lower part, right? So whenever I take this fault plane as a reference, upper part, lower part. So simple, remember, whenever this fault plane is there, whatever the wall which lies below the fault plane, that is considered as simple as a footwall block. And whatever the on the upper side you have, that will be my hanging wall block. In that way, that is the first point which I've explained here. And the second point, okay, if I talk about, okay, sir, if whatever the fault plane is there, if it is vertical, what happens? So in case of vertical, you may not see the footwall or the hanging wall may not be seen in case of vertical fault plane or the vertical fracture. So no footwall, no hanging wall, only in case of incline. So for that purpose, I also have put an image for your understanding. The next slide. Sorry. Yes. So here you can see this is a simple. So this is what is my fault plane, which is the first part of the fault, right? So as what I said, if you draw the fault plane, so you need to remember whatever the upper side is there. So this is the upper side, right? So upper side, or I can say rests on. So it is resting on this fault plane. So whatever the block resting on the fault plane will be a hanging wall block, and whatever below, that is lower side, the lower side will be my, or below, or I can say below the fault plane will be my footwall block. So similarly, the same way I have explained you with the reverse of this, right? Simple rock bed or rock strata, inclined fault plane, along this inclined fault plane. So upper side, what will be the upper side? So this is the upper side and this is the lower side. Upper side is what? Remember, always on the upper side, we'll be having the footwall. I try to uh, draw with the other. So this is better, right? So that is footwall. So which is on the upper side, or which rests on the fracture plane. And if I take the another one, another wall is what? Hanging wall. Another is hanging wall, which is below the fault plane. Hanging wall block, hanging wall block, and the footwall block. So these are the another part of a fault: hanging wall block and footwall block. Clear? Moving further, next part of fault is slip. So to understand slip, you need to understand a simple one, that is the displacement. So displacement, what do you mean by displacement here? Whenever I say displacement, I'm talking about the rock strata. So in a rock strata, because of the shear resistance, which is overcoming the tectonic forces, an inclined surface or fracture plane has happened, which is my fault plane, right? So because of this fault plane, what happens? Two walls which are on the either side, this is my simple foot wall and this is my hanging wall. This is my hanging wall, which are moving away. That is, we say it as slip. That is displacement that occur during the faulting is simply called as slip. In a simple words, on any I can say on any smooth surface or any what we are say, any type of surface, if you try to put your foot on that, you may see some slippery like nature. In the same way, along this fracture plane or fault plane, there will be some slippery or displacement taking place, because of which what happens, because of which I can say this foot wall will move downward and this hanging wall will move upward. This total displacement is known as net slip. And this may be along the strike direction or the dip direction or along both the direction. So if I take this one, so what is the strike here? This on the horizontal side is my strike, and this perpendicular to the strike is my dip. So similarly, in case of vertical fault also, we may see this part of fault, that is slip. In case of vertical, what happens? There will be no hanging wall, foot wall, as I said, only they'll try to move sidewards. That is in case of vertical fault. Clear? Moving further. So this is the third part of fault. Last, fourth is your heave and throw. Heave and throw. Coming to the heave and throw is simply a simple way of understanding, I can say. So whenever you see any if I take a simple one, so if I just try to draw a simple one like a staircase. So in a staircase, what you usually say? This is usually your thread. Usually say it as thread, right? And this we usually say this as a rise. In the similar way, here comes heave and throw. So whatever in the horizontal side, we usually say it as thread, and vertical side we usually say it as rise. In case of staircases, similarly in case of rock beds or the rock strata, whenever I talk about a faulting has occurred, faulting in a rock bed has occurred, right? So because of that faulting, this rock bed is being divided into two walls, separate walls, which one of this wall we usually say this as, which is usually resting on this, is my foot wall block, and which is below that will be my hanging wall block, right? So how to say which is heave and which is throw? Always remember, whatever the horizontal component of displacement is considered as a heave. If I take this block only, this block itself, if I take only this block, so how you can draw that block? You can just simply draw in this way. In this way, you can try just to draw the block, right? So whenever I try to draw this block in this way, so what is the horizontal portion? So this is my horizontal portion. Which is a heave. And this is my vertical portion, which will be my throw. So in a similar way, you need to draw for another wall on another side of the fracture plane, another side of the fracture plane, right? So similar way, you need to draw for another, sorry, and try to draw with a straight line so that you can understand simple rock strata. So in the similar way, you can see. So the another wall, if I try to draw neatly with a simple sketch here, so what you can say, again, in case of this, this will be my heave, this will be my heave. And in this case, this will be my throw, right? So in that way, simple, but horizontal component is H and vertical component with respect to V is my throw T. So, but in case of again, vertical faults, what happens? Obviously, there will be only throw. There will be only throw. If I try to draw a simple rock bed or a rock strata with respect to this, and in simple vertical fault plane here, vertical fault plane here. So in case of vertical fault plane, what you can see, you can mainly see only the heave, that is the horizontal component. See, vertical component is seen only that if the displacement has happened. I've just tried to show with the vertical that in that way. I'll try to explain that with the figure. You can see here in the figure, you can understand this very clearly. Like simple. If I take the slip component in the horizontal plane, see, if I take the slip component in the horizontal plane, only horizontal plane, if I take slip component, then you tried them in this way, heave and throw, right? But if I take both, that is the vertical component, heave and throw, weave and throw. Simple here I've shown you. You can see this will be my, sorry. For example, I'll try to show here. So this will be my heave, a simple horizontal component heave, right? So since the displacement has happened here, so along the displacement, whatever the part we consider, that will be my throw, right? Heave and throw. So that's the fourth component, heave and throw. So here what happens, whenever we consider a slip component in the horizontal plane and slip component in the vertical plane. So then I try to draw in this way, like strike, slip, heave and horizontal throw. Yeah, moving further. Next, after that, we talk about the classification and types of fault here. So similarly, as I've already discussed about the faults, so how we were dividing the faults. Whenever I talk about the fault, remember I'm talking about the rock beds are bent upwards and downwards. Rock beds are bent upwards and downwards. This is my anticline and this is my syncline. So in the similar way, if I talk about the fault here, sorry. If I talk about the fault here, so how we are classifying in the fault? How we are classifying? Like if they are bent upwards or downwards, we say it as anticline and syncline. And if they are undergoing the equal, that we say it as symmetrical fold or asymmetrical fold based upon the width of the fold here, width on this side like A and width on this side like B. So that one. And if I talk about the, so this was the first bent upwards downward and this was based upon the symmetrical. And third, as also I discussed about, so whenever I draw any fold, so I'm drawing about 2-3 folds here. So when I draw the 2-3 folds here, so this is my crest and this is my trough. This is my crest and this is my trough. So in case of crest and trough, depending upon the thickness, we usually differentiate them as open and closed fold. So in the same manner, faults are also divided based upon type of displacement along the fault plane and relative moment of whatever the footwall and hanging wall you see on either side of the fault, and they based upon the type of slip involved and mode of occurrence of fault. So based upon these 4 criteria, you can classify the faults. So I'll move the first one, that is depending upon the type of displacement here. So whenever I say type of displacement along the fault plane, simple, you can divide the fault into 2. One is translational fault and rotational fault. What is this translational fault and rotational fault? Is nothing but whenever I try to draw any rock bed, and in that rock bed, if I try to draw a simple fault plane, an inclined fault plane, in this case of fault plane, after that, if I draw this as the foot wall and this as the hanging wall, how this foot wall and hanging wall are moving. Based upon that, I say that as a translational fault and rotational fault. If I talk about foot wall with reference to the foot wall, right? Foot wall with reference to the hanging wall, if it is uniform and the displacement is uniform, means what? Whatever the thickness, whatever the width you see here, the same width are seen on this side also, then that is considered as a rotational fault. And in case of rotational fault, sorry, so whenever the width of the fault on the either side is equal, then it is translational fault. If the width varies, then it is a rotational fault. Similar way, I have tried to explain the next classification and type of fault, that is relative moment of the foot wall. So here, whenever I talk about the relative moment of the foot wall, here I will be talking about again with respect to the foot wall and hanging wall, a simple rock strata or the rock bed. Along this, I'll try to draw in the other way. So this is the inclined fault plane. So whenever I draw this inclined fault plane, remember whatever on the upper side will be my foot wall, and whatever on the downward side will be my hanging wall. Right. So now with respect to the relative moment of the foot wall and hanging wall, in case of inclined fault, yes, this is an inclined fault plane. So in this case, what happens? If I take now hanging wall goes down with reference to the foot wall, like here I can see what is in this case. In this case, what happens? Obviously, this is going down and this is going up. This is going up. So if this is happening, then we usually say that as a normal fault or a gravity fault. Because of the gravity, the hanging wall is moving downward. And with reference to that, foot wall is moving upward. Then we say that as normal fault. Also, another name for that is gravity fault. Right? So other point which I've mentioned here, very appropriate, because hanging wall is normally expected to move downward along the slope of the fault plane under the influence of gravity. See, fault plane inclined in this way, right? So it is inclined in this way. That's why the hanging wall, since it is downward or below, or I can say at the lower side, and this is upper side. That's why hanging wall will try to slide downward. That's why we say if the hanging wall is sliding downward, we say it as a normal fault or gravity fault is happening. And if it is reverse, if I say, for example, if I draw this rock bed or the rock strata again, and if I try to draw that fault plane again along this side, and if I say the whatever this hanging wall is there, this hanging wall is moving upward, that is reverse direction, and foot wall is moving downward, then we say it as syncestral fault, which is another type based upon the relative moment of foot wall and hanging wall. Right? Syncestral and reverse fault. Yes, just a minute. Yes, here you can see. So this is just a normal fault, which are discussed before. Normal fault, foot wall and hanging wall. So whenever I say foot wall, hanging wall, along the fault plane with reference to the fault plane, because of the gravity, whenever the hanging wall is moving downward, then we say it as a normal fault, or you can say that with another name as a gravity fault, right? So in a similar way, if I try to draw another part of this, another side of this for the normal fault, simple, this is the normal fault. This is the normal fault, right? If I try to draw here, this is my inclined fault plane. So along this inclined fault plane, if I try to show you whatever the rests on the fault plane, so what we say that we usually say that as a hanging wall, and whichever is below, usually say that as a footwall. See, for this always you need to understand the parts, whatever I've discussed before. Here you can see, whenever I discuss these parts, what I said, whichever lies below the fault plane is footwall, and whichever rests above the fault plane is hanging wall. Always remember that. Based upon that, you need to draw here. You need to draw the figures. So whenever I try to draw the figures, remember, I'm writing that with respect to the part of fault which I explained. Like if I say here, this is the inclined fault, opposite to this I'm writing, so that another fault plane you can understand. So whichever whichever rests, right, hanging wall, and just a minute. Hanging wall, and whichever is below is the footwall. So since hanging wall is resting, and if it is moving downwards and footwall is moving upwards, then we say it as a normal fault, or what I said, gravity fault, gravity fault, gravity fault. And reverse of this, what happens? If I say reverse of that, what will be the reverse of that? That the hanging wall or the foot wall, if I take that as a reference, if the hanging wall is moving upward and the foot wall is moving downward, then we say that as a reverse. Then we say it as a reverse fault. So this is another classification based upon the relative moment of foot wall and hanging wall. So this is a simple fault plane which is inclined in this direction, and the dip is in this direction. And if the inclined is in this direction and dip is in this direction, so then the reverse fault, again we should say in the reverse way, that hanging wall is moving upward. The hanging wall is moving upward, reverse fault. If the hanging wall is moving downward or because of the gravity, then it is the normal fault. After that, we have the other, whatever I've said already, like syncestral fault. That is one here, syncestral fault, which is another with respect to the relative displacement of hanging wall is neither upwards or downwards. Then we say it as a syncestral fault, which is mainly because of the what? Because of the sideward movements which is happening at the fault. Simple. If I try to draw a simple fault, and in this fault, mainly we see in case of vertical, in that case we see that one. So if I say vertical fault plane is there, in this case what happens? Whatever the walls are there, they'll move sideward. Usually I just drawn this indication which indicates sidewards movement are seen, right? Maybe I'll put an image for your understanding. What is the syncestral fault here? Yes, here you can see. So this is a simple syncestral fault. You can see here. Fault you can see here. Left with another 2 to 3 minutes. Yes, so you can see a simple fault. So you can see this sideward movement, because of what? Because of, as I said, a vertical fault happening. Because of the vertical fault happening, because of that only you can see this vertical fault. If I try to draw with the red line here, I try to draw side here. So this is the red line, which is a fault plane because of the vertical fault. The blocks, we will say blocks because we cannot say that as a foot wall and hanging wall because they are not undergoing any inclined fault. So that's why we say that as a simple block. And these blocks are moved sideward. Then we say them as they are showing another type or classification of fault called as syncestral shearing fault or simple syncestral fault. So that was the second classification based upon the relative moment of hanging wall and foot wall. And next, based upon the types of slip involved, if I say, what is this? What is a slip? So whenever I say sorry, whenever I say slip here, I'm talking about how this hanging wall and the foot wall are moving away. So whenever I say how they are moving away is nothing but simple block. In a simple block rock strata, whenever an inclined plane is being seen, and in that inclined plane, if I show that inclined plane with you with correctly there, so you can understand me. Usually the slip happens along this inclined plane itself. So the slip happens because of this slip happening mainly due to the relative displacement. That's what, if a slip if the displacement is along the strike direction of fault plane, such fault we said as strike slip fault. And obviously if the strip was what are the slip that we usually see, the displacement we usually see in another direction other than strike, if this we usually say them as oblique slip fault, that is partially in strip direction and partially in another direction, that we said as oblique slip fault. Here you can see this is a simple strike slip fault which is happening along the strike direction. Maybe the meeting is going to end now. I already taken the attendance, no need to worry. So you can see this is the strike direction which I'm drawing with the red color. Along the strike, if the slip is occurring, then it is a strike slip fault. And if it is partially occurring in the strike and partially occurring in the another direction, partially here and partially in the dip direction, then we say that is it is an oblique slip fault. So that's it. Maybe I left with another classification, I think, right? That is based upon the mode of occurrences. This I'll be taking in the next class, possible tomorrow, right? And after that, I'll move to some miscellaneous type.